Thank you very much for having me. You introduced me, so I can skip the bio slide when I get to it. That saves us a bit of time. I'm from Kongsberg Defense and Aerospace, as you mentioned, and we're protecting people on planet. That's our brand new slogan, and I think it's very suiting to what we do. We're a developer and supplier of world-class defense systems, and we have been doing that for 210 years. We're the oldest industry company in the world, actually. So I would like to say a little bit about, just quickly about the products that we show here. Maybe the laser is a bit too weak, I see. We do these, for instance, these weapon stations here, and I would say it says a lot about the mindset in Kongsberg Defense and Aerospace that we're protecting people on planet. This weapon station allows the gunner to sit inside the tank during operation, significantly reducing the stress level of the gunner and also significantly reducing collateral damage caused by stress from the gunner. We've been a royal supplier of weaponry to the Norwegian defense forces for our entire existence, and this about creating deterrents that should keep the enemy at bay has always been the strategy. I'm very proud to say that we are in Ukraine defending civilian lives with the air defense system called NASAMS at the bottom there, saving hundreds of lives every day. I'm very proud of that, so I wanted to make sure you all know about this. I work in this segment. I manage system architects in the missile division in KDA. And just to introduce why is model-based systems engineering so important to us? Well, to develop a missile, you need to have 350 engineers working at the same time for nearly 20 years. The requirements are extreme. It's you're supposed to operate in the Norwegian Sea, so you need to operate within those environmental conditions. You need to hit the target, no matter what the weather is like that day or how good your data is. There's absolutely no room for error. We need to be resilient to all external factors. You can't produce a missile that's hackable these days. Cybersecurity and that kind of things is very important, and you need to be robust against whatever you meet out there in the real world. You need to be safe for the end user. Maybe not safe for what you want to hit, but safe for the end user of your products. And we're very, very highly regulated business. We are audited every year not just by auditing companies, but by our customers. It's a very, very highly regulated business. And at the final thing there, the missiles need to win the day, any day, every day. So it's, we really need to have a control of the entire design, the functionality of the system, and what it's supposed to do, what's the targets for it. So quickly, my bio was already there. Why should you listen to me? Well, I have 14 years of experience. So I'm trying to share a little bit of that. Today, I want to use this opportunity also to start with defining model-based systems engineering, expand a little bit on what Johannes started here in the first presentation. So just quickly, hands up, how many here are familiar with model-based systems engineering? Quite a good set of hands. Great. Let's see if you agree with my definition then. So I would say that systems engineering, traditional systems engineering, is about three things. First one is the problem, finding out what does the customer actually want, how much are they willing to pay to acquire it, how much are they willing to pay to own it, what kind of effect does your product need to produce, how should it fit within their organization. Next, you need to conceptualize this into something that's actually feasible, that it will actually work. You're actually able to produce it. It will actually produce the effect that you said it's supposed to do. And last of it, you need to productify it, make it profitable, make it marketable in such a way that it's compliant with regulations. It's attractive to other customers than the one paying for the development, for instance, in order to get the market share that you want. And that causes us to have what I call the three-body problem of systems engineering, because these three domains need to be balanced out, and you have no idea going into a project what weight you should put on each of these three domains. So that's in constant development throughout your first half of your project at least. And that's where model-based systems engineering comes into the picture, because working in these three domains, you generate, as Johannes showed just earlier here, enormous amounts of data in different data sets. And if you work in document-based, this is what your world looks like. Each dot here is a data set, your safety analysis, your resilience data, your FMEAs, your life cycle cost analysis, your requirements analysis, a lot of different data sets. What MBSE enables you to do is to connect these data sets, and suddenly you have a visualization of where you're actually going. And that takes me back to what I said, 350 plus engineers working for nearly 20 years. How many design decisions do you think they make each and every day? If they don't know exactly where we're going, what the target is, their trade-off analysis is going to be wrong. You can't have one chief engineer checking all the decisions. You need to make sure they all understand that what we're making is in fact what the data is visualizing. And also you may find out that there's some data you don't need. And then you can skip those kind of things in your next project and become more efficient. So how does MBSE enable us to do this protecting people and planet? Johannes started with the V model. Very good. It's a very well-known way of working in systems engineering. I'm going to expand on it to become an X model, and also show the tool sets that we're using now, and also show how Technia and Dassault are helping us achieve our goals. So this V model is familiar to anyone in systems engineering, but I've expressed this now as the data we produce during the V model. So on top left corner you have the as requested. That's where we document how we understand our customer. This is what we think you want, and we work with the customer to make sure that we've understood them correctly. Then the as offer, that's what we show to the customer. This is what you're going to get. Based on how we understood your problems, this is what you're going to get. And then we're going to specify this to our designers. This is how we specify it, and then this is how we're going to design it, and all the way. Through this V model, we generate a lot of different data that needs to show, and data that will be used in different parts of the life cycle of the product. And I didn't mention, a missile has a life cycle, a single missile has a life cycle of 30 years. So once it leaves a factory, it's going to live for 30 years. Missiles as a family, our oldest missile called the Penguin was developed in the 1950s. It's still in operation. So, of course, midlife upgrades and so on, but it's the life cycle is huge. It's not going to be the same people maintaining it that developed it. You can't have this human-to-human exchange of knowledge, unfortunately. And also, the circular economy stuff is becoming more and more important in the defense industry as well. Last time I was here in Stockholm speaking to Technia, the presenter before me was talking about circular economy, and as I entered the stage, I got the question, is KDA circular? And I panicked, because that was the first time I've heard about it, so I answered, we make missiles, not boomerangs. Since then, I have learned that we are in fact very circular, because the mechanical parts we design for missiles, then when you design them to last 30 years, they're also going to last 100 years. So we can actually buy back missiles, refurbish them, and sell them again. Anyway, the X model. So what we do, also showed by Johannes, we create models along all these steps. And these models become are representations of what we need from the V model. We use the problem domain models to express how we understand the problem for the customer and all the other stakeholders. We use the conceptual architecture model to express to the customer and also internally, this is what we're going to make. And then we can do the solution architecture model to start with the specification. We don't just use requirements anymore, we use the entire architecture as a specification for our products. That takes us on to the design models, the physical models, the assembly models, the verification models, compliance models becoming more and more important, as I mentioned, for instance, with sustainability and other regulations that we need to comply with. How we're going to deliver it and how we're going to service it. All of these are models, and we need to also integrate these models, not just to produce the information that these yellow arrows represent, but also to store it. So our current setup is that we have a Innovia 13x database, PDM database, that we store all these as requested, as offered, and so on, that information there. And then we have a separate 3D experience setup that we use to create these models. And I'm going to say a little bit more at the end on how we're moving on from that. We use CATIA Magic for this part, these models down here. All these models are done in CATIA Magic. Johannes showed some slides on what a diagram looks like, so I'm not going to go into that now. Just going to tell you this is where we do these things. And it's using SysML in CATIA Magic is a very strong tool to get an understanding of where we're going and to also share the information and store it so that it can be reassessed or reused in the future. We also do software in CATIA Magic, and so this line or this area extends a little bit into the design models, and I can say from CATIA Magic we've been able to produce I think it's 110,000 lines of validated infrastructure code from a single developer in a year. That's massive, but that's what we did 10 years ago. So we've expanded a lot from that. That's an old measure, but it's also a very strong point of why modeling is so good, because you can generate code from it as well. We have this CATIA and Simulia setup in 3D Experience, where for our physical models we use Delmia for our assembly models and also for our plant layouts. We have a new missile factory that opens in 2 weeks, completely modeled in Delmia. We use Innovia requirements to get our requirements in place, which is part of the solution architecture model. We use the and also do our verification planning, test results capture, and all that in Innovia. And also we do a lot of compliance. We have the materials compliance module as well. But we don't have this yet. So there are limits to what we're doing as well. This is how far as we've come right now. And the challenge right now is that we still have separate databases for these two. I'll get back to that. We have integrated this world with the verification world, but we are not yet at the phase where we've really connected this world with the hardware engineering world. That's one thing we haven't been able to do yet, but we're working on it. And we're looking into the areas of delivery and service this year. Actually, we're doing that with Technia in August, looking more into that. So this is the current KDA X model. These are the tools that we're using. Broadly speaking, there's more, of course, but just to show that in order to document all these things in the V model on top that we need to have in place, this is the tools that we use. We have some interesting statistics, for instance, with Delmia, which is able to, we're 4 times more efficient in Delmia than in our old tool setup. And we've done that in control group settings, so we know those numbers are correct. We really see a very big benefit to going model-based. Communication is better, we have fewer iterations, and we also see that when we don't use model-based systems engineering, it tends to at least have 3 times the iterations. And after 2 iterations, they come to me and say, can you please model-base it for me? And then we fix it. So it's a very strong case, and I would say 3D Experience does really offer what I showed in the first slides here with these connected data sets. So a little bit, I'm going to brag a little bit about us and also about Technia. If we go back to prior to 2016, our world consisted of the systems architecture and the requirements in different databases. We were doing a lot of analysis that were produced into documents, a lot of document-based engineering. Together with Technia and Dassault, or at least Technia was the able to bring Dassault into cooperation with us. And what we did up to 2017 is that we were able to integrate what was called Magic Draw back then with 3D Experience. Then Dassault acquired Magic Draw, so now that's delivered out of the box, but we made that first integration. And I see that that's become an out-of-the-box solution now, so you're welcome, Dassault. Still, some things are in the document-based world, but what we're able to do in 3D Experience that, okay, if we export something into documents from another tool, we can still put it into 3D Experience and connect it to the exact correct version of an architecture. That means that we are in control of what we're doing and that we're actually responding to the right version of a design without having to manually keep control of that. And now, as a final here, we're working now in 2024 with Technia and with Dassault. Our goal is to connect this full X model. So bring an end to our 13X Enovia, go full PLM in 3D Experience with the CATIA Magic integrated, and also look into a lot of new stuff. And we're working on a 20-year strategy and roadmap for our digital engineering efforts. And that's the conclusion of my talk.